All right, continuing on. So two things to determine the inverse, you can reverse the coordinates of the ordered pairs. So you're going to switch x and y. You can reflect the graph in the line y equals x. Or if we start thinking about an equation, what we want to do is we want to interchange x and y in the equation and then resolve the equation for y. Okay? Just a side note, when we talk about domain and range, because our x and y values are literally switching positions, that is what's going to happen to our domain and range. So the domain of the original function is going to become the range of the inverse function. The original function is going to become the domain of the inverse function. All right, so just some examples of inverse functions, right? So here is a linear function of 3x plus 6. The inverse function would become x minus 6 divided by 3, and we'll get into like how to get this equation. And so you can clearly see a reflection of this line through the line y equals x. Okay, again, this is our original function g. The inverse function would be this reflection in the line y equals x, so our new function would look like this. One thing to note is that your invariant points are going to be the points that actually occur on the line y equals x. So let's just make a note. Invariant points will occur on the line y. So invariant points always occur on that reflection line. Okay, so for example, given the function f of x is equal to the absolute value of x minus 3, sketch y equals f of x and state its domain and range. So steps: 1, sketch its inverse, state the domain and range of the inverse. Is the inverse a function? If not, how could you restrict the domain of the original function so the inverse is a function? So let's just revisit what a function is. A function means that it can only be one y value for every x value, or it has to pass like the vertical line test, right? So looking up here, if I were to draw a vertical line through this graph, it's only intersecting this one time. So same with this graph is a function. These lines are functions, okay? Back to our example over here was a function. The inverse is not a function because intersecting it 2 times. Okay? All right, so moving on. Sketch the following function. So absolute value of x minus 3. So thinking back to visualizing what this graph looks like, right? It takes that V shape that would normally start at the point 0, 0, but this minus, we're going to move that graph 3 units down. So technically the graph should start here. It's going to take the shape of a V. For every 1 unit over, it moves 1 unit up. Right, so it's always good to have a good sense of what that original function looks like. Okay, so here's our original function, y equals absolute value of v. We want to sketch its inverse. So as you notice, I kind of sketched this first graph fairly lightly. I'm going to draw my inverse a little bit darker. So I'm literally going to take a few points on this graph, and I'm just going to interchange my x and y values. So this point here at negative 3, 0, that point would become, so negative 3, 0 becomes 0, negative 3, which is already here. This point here at 0, negative 3 becomes negative 3, 0, which is here. So I think of, okay, also we're reflecting in this line. It might be hard to see here. So I'll just slightly draw my line y equals x. Okay, we're reflecting. So this point is going to reflect here. This point is reflecting here. And then this point, which is at 3, 0, is going to reflect to 0, 3. So what happens is that this vertex point at the peak actually is now here. So now we get something that looks like this. Okay? And even though these two graphs kind of end up on each other, the only invariant point would be this guy right here that's on the line y equals x. State the domain and range of the inverse. Well, the domain of the inverse would be anything greater than -3 or equal to. And the range would be anything, would be all real numbers. Which is kind of the opposite function. So let's just talk about the original function and its domain and range. The domain of my original was all real numbers, right? So this is my original. And the range would be anything greater than or equal to -3. So as you can see, right, as you can see, the domain and range have literally switched. Once was all real numbers for x is now the range for the inverse. Once greater than or equal to -3 is now the domain. So the next question is the inverse a function? So if I were to do a vertical line test anywhere on here, this would not be a function. No, it does not pass the vertical line test. If not, how could you restrict the domain of y equals f of x so that inverse is a function? Okay, so what is creating this to not be a function, right? It's having to pass through both of them. So either I want to restrict the original function so it is one part of this v. So either it graphs this part, but we want to restrict the original function so that when we inverse it, we just get one line. So that really is talking about the domain of this original function. And again, I only want to, so that means I only want to graph one part of this v, either this part of the line or this part of the line. So how would I restrict my domain? Normally my domain is all real numbers, but now I want to restrict it to just either this line or this line. So what am I going to say about my domain? So in this case, I'm either going to restrict my domain to everything less than 0, or I'm going to restrict my domain to anything greater than 0. Okay? So how can I restrict my domain? By saying x has to be less than or equal to 0. That would mean that the graph would only appear for this line, or anything greater than or equal to 0. Okay. So we do a vertical line test for the inverse function, right, to determine whether it's a function or not. So what does that mean? How can we determine if the inverse is a function just by looking at the original function? Well, we can do a horizontal line test of our original to determine if the graph of the inverse will be a function. If it is possible for a horizontal line to intersect the graph relation more than once, then the inverse of the relation is not a function. If I did a horizontal line test of my original function, it intersects it 2 times, so this tells me that the inverse will not be a function. Okay? All right, example 2, determining the equation of an inverse. Okay? Key idea here, we want to interchange our x and y values and then solve for y again. So we're going to resolve the equation for y after we switch them. So technically we can recognize that f of x is really our y value. So to solve this, I'm going to switch my x and y coordinates, and then I'm going to resolve the equation for y. So I would subtract 6 from both sides, and then I would divide everything by 3. So x divided by 3 minus 6 divided by 3 would give me 2. So this would be my inverse function equation. Okay? All right. If you're given the function x squared minus 4, okay, we're going to determine two ways we can find the inverse at 4. So what is this asking? This is asking to find the y value when x equals 4 for the inverse function. Okay? So let's just write that. 4 is the x value on the inverse function. So what does that tell you about the original function? So this tells me, therefore, 4 is the y value on the original function. So what am I going to do to that 4 in order to solve this expression? Well, I can substitute 4 in for my y value and then solve this equation for x. And so the x value of my original is going to represent the y value of the inverse. So by adding 4 each side, taking the square root, and so I need a plus or minus here, okay, because I'm taking the square root. And then I want to simplify this radical. So to simplify that radical, what square root can divide into 8 evenly, or x squared, sorry, would be 4. 4 times 2. I'm now going to take the square root of 4. So the answer for the inverse of 4 would be plus or minus 2 root 2. Okay. All right, your turn. Given f of x equals x over 3 plus 2, determine the inverse and draw both relations. All right, so if I wanted to determine the inverse function, I'm going to interchange my x and y values. So I'm going to switch x and y. So this is going to be x equals y3 plus 2. I'm going to subtract 2 from both sides. And then I'm going to multiply everything by 3. All right, so if I wanted to draw these two relations, either you can just draw each of these line segments, or you could draw this and then reflect in the line y equals x. It's totally up to you. So I'm going to draw my original as a dotted line, and then I'll draw my new as a solid line. So this is just a basic linear function. The y-intercept of this is 2. I can get my slope of the line from the value in front of x, which would be 1 over 3. So I'm going to rise up 1 and over 3, or I could go down 1 and to the left 3. I'm going to take my ruler. I'm going to draw a dotted line for my original function. Okay, there it is. My new function. The y-intercept is a -6, a little bit off the page. My slope now is 3 over 1. So you see how everything's kind of opposite. The slope here was 1/3. This is now 3. The x-intercept of this function was -6. The y-intercept is now going to be -6 for the inverse. So my slope is 3. 1, 2, 3 over 1. Do it one more time. Look here, the y-intercept was 2. The x-intercept is now 2. I'm going to sketch this graph. Draw this as a solid. Okay. 3, 3 is our invariant point. Not that it's talking about asking us to find that, but let's just identify it. And then determine the inverse at 10. Well, the inverse at 10, because I've already solved the equation, I'm just going to substitute my x value into my inverse function. So 3 times 10 minus 6 would give us 24. Okay? And then lastly, example 3. It says, given the function f of x is equal to x plus 4 all squared, comma where x is greater than or equal to -4. So this tells me that I am not actually going to graph this entire function. I'm only going to graph this function for my x values that are greater than or equal to -4. So sketch this, thinking about a basic parabola that would normally start at 0, 0, has now moved 4 units to the left. So here's my vertex, and I'm only graphing this for values that are greater than or equal to -4. So I'm only graphing this part of the function. Once again, I'm going to do this as a dotted line because it's asking me to graph the inverse function. Okay, so here it is. That is only relating to that domain. Determine f -1 of x. So this means I want to find the inverse function of this with the restricted domain. So determine this. So I'm going to solve this. So I'm going to interchange my x and y values. I am going to now rearrange and solve this for x. Okay? So because they are equal to -4, or we'll just do the whole thing and then we'll go back. So I'm going to take the square root of this. When I take the square root, I definitely need a plus or minus root x in front of it. And then I'm going to... Okay, so there is my new function. Y, sorry, not 0. Now I need to figure out the new restricted domain on this so that the inverse function doesn't graph me the entire sideways parabola, that I'm only inverse of this. So how do you do that? Well, technically the inverse function is going to relate to the domain or the range of the original function. So if I talk about the domain, or sorry, the range of the original, would be y has to be greater than or equal to 0. Okay, so that tells me that the domain of this function is going to have to be x is greater than or equal to 0. So that would be my function with my restricted domain. Okay, so because this original function only graphed this portion of the graph, I don't want to graph both my positive and negative values. If I were to obviously interchange this, this is going to reflect to here, this in here, this is reflecting here, and so on. So I'm going to get a graph that looks something like this. So another way you can tell is by drawing this line, y equals for the inverse function. So technically this portion of the graph only relates to root x, not the negative. So I'm going to just change this equation to just root x minus 4, where x is greater than or equal to 0, and that would give us our and that is inverse functions.